Hello viewers, welcome to Deepu's Chem classes. So I'm putting videos based on 11th chemistry of Tamil Nadu government syllabus. So please kindly pause this video to all the 11th students so that they will be benefited. So today we will see the continuation in chemical calculations. So let us see redox reactions in terms of oxidation number and types of redox reactions. So let us see redox reactions in terms of oxidation numbers first. So first of all, what is redox reaction? So redox reaction, I think you may studied in lower classes. Anyway, I will explain now. So redox reaction is nothing but reactions which involve both reduction and oxidation. So if the reaction involves both reduction and oxidation, then it is called redox reaction. That's why we abbreviated the term. In redox, RED stands for reduction and OX stands for oxidation. Okay. So usually a redox reaction accompanies with some changes in oxidation numbers. So how redox reactions can be expressed in terms of oxidation numbers? So let us see. So when a reaction occurs, usually an element from reactant side will be changed into product, accompanying along with some changes in oxidation number. So if the oxidation number increases, then the process is said to be oxidation. Okay. Suppose if the oxidation number decreases, then it is said to be reduction. So let us see examples. For example, reaction of potassium permanganate with ferrous sulfate and sulfuric acid. Okay, gives the products potassium sulfate, manganese sulfate, ferric sulfate and water. So in this reaction, so you have to first find out the oxidation number of the element which shows variable oxidation states. So for finding out the oxidation number, you please refer my previous videos. So in KMnO4, the oxidation state of manganese is +7. So which will be changed into +2 in manganese sulfate from product side. Okay. Do you understand, ma? So in potassium permanganate, the oxidation state of manganese is +7. That's you have to calculate. Okay. Then from product side, manganese has the oxidation number +2. So from +7 to +2, the oxidation number decreases. Then the process, if it decreases, what is the process called? Reduction. So oxidation number decreases. So process is called reduction. Similarly, in ferrous sulfate, the oxidation state of iron is +2. But the oxidation state of iron in the product, okay, ferric sulfate is +3. So +2 is changed into +3. Oxidation number is increases. So if oxidation number increases means what is the process called? Oxidation. So here it is said to be oxidation. So the overall process involves both oxidation and reduction. So it is a kind of redox reaction. Okay, do you understand, ma'am? Let us see the types of redox reactions. Actually, the types of chemical reactions you may studied in 10th standard: combination, displacement, double displacement, decomposition reaction. So here also some more or less the same concept you are going to study, but how it accompanies both oxidation and reduction. So here we are going to study that too also. Okay, right. So the first one among the types of redox reaction is combination reaction. Okay. So usually a combination reaction involves a combination of two elements or two compounds which leads to the formation of a single product. That is actually called combination reaction. So if the combination reaction involves both oxidation and reduction, that is, if you say that is redox reaction, then it is called combination redox reaction. Okay, so let us see example. The simplest example is formation of carbon dioxide from carbon and oxygen. So when carbon reacts with oxygen, we can get the product carbon dioxide. Let us see where the oxidation occurs and where the reduction occurs in terms of oxidation number. So carbon in reactant side has oxidation number 0. but in product side it shows +4. So that means oxidation number increases. If it increases, what is the process called? Oxidation. So in in reactant side, oxygen has the oxidation number 0 because both carbon and oxygen in the elementary form. Okay, right. So oxygen has the oxidation state 0. Well, but in product side it has the oxidation number -2. Okay, so 0 to -2, it is decreases. So oxidation number decreases. Then what is the kind of reaction? It is reduction. So it is the simplest type of combination reaction. It involves both oxidation and reduction. That is, it's a kind of redox reaction. Okay, do you understand, ma? Right. So let us see the second type of classification, or second type of redox reaction, that is decomposition reaction. So we know very well decomposition is nothing but breaking down of a single compound into two or more compounds. That is actually called decomposition reaction. So same here, if but what is the main condition here? If it accompanies both oxidation and reduction, then it is a kind of decomposition redox reaction. Okay, right. So let us see example. So the simplest example is thermal decomposition of potassium chlorate. Potassium chlorate, okay, when it undergoes heating, what will happen? You can get the product potassium chloride and oxygen. In potassium chlorate, chlorine has the oxidation state +5, but the same chlorine from in product side, okay, when it changes into a product potassium chloride, it shows the -1 oxidation state. So it +5 changes into -1. So what will happen here? Oxidation number decreases. Then it shows reduction. Okay, then it shows reduction. Then if you see the oxidation number of oxygen in potassium chloride, it is actually -2. But if you see the oxidation number of oxygen in product side, it is 0 because it is in elementary form. So it is 0. So -2 to 0, that is minus charge to plus charge. It is actually indicates oxidation number increases. So if it increases means what is the process called? Oxidation. So it is a kind of decomposition reaction because a single compound is breaks into two substance here. So it is a kind of an example for decomposition reaction which involves both oxidation and reduction. So it is actually called decomposition redox reaction. Okay. Then let us see the third kind of classification, displacement redox reaction. Usually displacement we know very well. When a compound reacts with another compound, a compound displaces, for example, when AB reacts with CD, okay, one compound displaces one of the species from another compound. Similarly, instead of the displaced species from another compound, one of the species is substituted. So it is actually a kind of replacement reaction. Okay, so let us assume B is displaced over here. So we can get AC plus BD. Okay, it's a kind of double exchange reaction or double decomposition reaction or double displacement reaction, you can say. But if it involves both oxidation and reduction, then what it is called? Displacement redox reaction. So but here we have two types of displacement reaction. If the displaced, okay, if the displaced element, okay, if the displaced element is, if the displaced element is a metal, then the kind of reaction is metal displacement reaction. Suppose if the displaced element is a non-metal, then it is non-metal displacement reaction. Do you understand, ma? So among the two compounds, one compound replaces one of the species from other compound, then it is called displacement reaction. So let us see example. In displacement reaction, let us see the first one, metal displacement reaction. So let us see example for that. So copper sulfate. we know from this example you may studied in 10th standard itself. So copper sulfate, it is actually blue in color. When you add zinc to this blue colored copper sulfate solution, so after chemical reactions, what will happen? The blue color of the solution slowly disappear. Okay, slowly disappear, and instead of that is actually due to the displacement of copper by zinc. Okay, otherwise zinc release electron into the solution, copper accept that electron and changes into elementary form metallic copper, so that you can get a product copper plus zinc sulfate. Simply, when you add zinc to blue colored copper sulfate solution, zinc replace copper from copper sulfate solution, and instead of zinc is substituted over there, so you can get simply copper in the metallic form, or the individual form. Okay, and zinc sulfate is obtained as a product. So here, if you see, copper has the plus 2 oxidation state in reactant side, but copper has 0 oxidation state in product side. So plus 2 to 0, oxidation number decreases, then it is actually reduction. Then zinc has 0 oxidation state in reactant side, but it shows plus 2 oxidation state in product side. So 0 to 2, oxidation number increases, then the process is called oxidation. So it is a kind of metal displacement redox reaction. Okay, because the displaced element is also metal here. The second kind of displacement reaction, let us see, um, non-metal displacement. For example, reaction of zinc with HCl. Okay, so reaction of zinc with HCl, we can get the product zinc chloride and hydrogen. So it shows very clear. Now the metal displaces what here? A non-metal, hydrogen. So the displaced element is non-metal here. Okay. So based on that, it is classified. Remember one thing well, based on the displaced element, if it is metal or non-metal. So based on that, it is classified into metal displacement and non-metal displacement. Zinc shows 0 oxidation state in the reactant side and plus 2 oxidation state in product side. So it indicates the oxidation number increases. So if it increases means what is the reaction called? Oxidation. Okay. In reactant side, hydrogen shows plus 1 oxidation state, but product side it shows 0 oxidation state because it is in elementary form. Okay, elementary form. So Z plus 1 to 0, oxidation number decreases. So oxidation number decreases means what is the process called? Reduction. Okay. So let us see the fourth kind of redox reaction, disproportionation reaction. It is otherwise called auto-redox reaction. In certain reactions, only one compound undergoes both reduction and oxidation. Otherwise, if you say only one compound involves the changes in both oxidation number, either decreased or increased. So such a kind of reaction is called disproportionation reaction. So let us see examples for that. The first example, the first example for that is decomposition of hydrogen peroxide. When hydrogen peroxide decomposes, we can get a product water and oxygen. In hydrogen peroxide, the oxidation state of oxygen is -1. Okay, but in water from product side, the oxidation state of oxygen is -2. So -1 to -2. What it means? Negative charge increases. That means oxidation number, it shows oxidation number is decreased. So then the process is called reduction. Okay. Then similarly, oxygen, the oxidation state of oxygen in oxygen from product side is 0. So -1 to 0, it shows oxidation number increases. Then what kind of reduction it is? Oxidation. So if you observe well, so it shows clearly the same element oxygen. When it changes into water as a product, oxidation number decreased. When it changes into oxygen as a product, then oxidation number increased. The same element undergoes both reduction and oxidation. So it is a kind of disproportionation reaction. So another example you can say, combination of chlorine and potassium hydroxide. So when it combines, we can get the product potassium chlorate, potassium chlorate and water. So chlorine in reactant side has the zero oxidation state. It has -1 in potassium chloride and +5 in potassium chlorate in product side. Okay, so 0 to -1 oxidation number decreases, so it indicates reduction. 0 to +5 oxidation number increases, it shows oxidation. So same element chlorine undergoes both reduction by showing changes in oxidation number. I mean, by means of forming potassium chloride, it is the oxidation number gets decreased. By forming potassium chlorate, the oxidation number increases. Okay. Then let us see the final classification of redox reaction, competitive electron transfer reaction. So previous example, that is in displacement reaction, we have seen one example. What is the example? Displacement of copper from copper sulfate solution by zinc metal. Okay, just let us assume the reverse reaction of that. Suppose let us take zinc sulfate solution. When it treated with copper element, whether it displaces zinc from zinc sulfate solution. Suppose if it displaces means what is the product you might get? Copper sulfate. There is a formation of blue color and zinc metal. But in actual practice, the reaction doesn't occur because compared to zinc and copper, zinc only has the tendency to release electron, copper only has the tendency to accept electron. The one which release electron only displays another element from the compound. Okay, so remember this thing. If you take copper and zinc sulfate solution, the reaction usually don't occurs. But if you take zinc and copper sulfate solution, the reaction occurs because zinc can able to displace copper from copper sulfate solution because of the releasing nature of electron releasing nature of zinc. You can get the product. Okay, right. So let us see another example. Reaction between copper and silver nitrate. Okay, when you add copper to the silver nitrate solution, copper metal to the silver nitrate solution, what will happen? So slowly the color changes. The color of the solution changes into blue. That means the reaction actually occurs. Okay, copper can able to displace silver from silver nitrate solution so that you can get the product copper nitrate and silver metal. Okay, so the blue color formation indicates the chemical reaction is occurred there. Okay, right. So if you see copper in reactant side, it has a zero oxidation state, but when it changes into the product copper nitrate, it shows +2 oxidation state. So it shows the oxidation number is 0 to 2 means oxidation number increases, then the process occurs, there is oxidation. Okay, but silver shows +1 oxidation state in reactant side, but when it changes into metallic silver, it shows 0. 0 means in elementary form it shows 0. Okay, so +1 to 0 oxidation number decreases, so it shows the process is reduction. Okay, so from this you can understand among the metals zinc, copper, and silver, zinc shows high electron releasing nature than copper, which shows high electron releasing nature than silver. So, when zinc and copper reacted, zinc can displace copper. When copper and silver reacted, copper can displace silver from the another compound. But the reverse reaction is not possible. Okay, reverse is not possible. Remember. So that's all about the types of redox reaction. So let us see the remaining in the next class. So please give valuable comments to my teaching and as well as please like, share and subscribe my channel. Thank you.